Hello guys, hope you are doing well. This video is a complimentary video for the chapter 1 section 2. In the first video, the first part of the section, we talked about the colligative properties and their relation with the molality, and we have solved several questions on how we can calculate the boiling point and freezing point with the elevations and depression as well. Today we will be talking about the electrolytes and colligative properties, because so far we have talked about the non-electrolyte solutes. We'll be talking about the electrolytes and the colligative property, and later on we'll be talking about the differences between actual and expected value of the electrolyte solutes. But from the colligative properties in the first video, which we talked about, guys, some part remains. We talked about the osmotic pressure, and we said the osmotic pressure must be applied to stop the osmosis whenever there is different solutions with different concentrations. What's the application? What's this osmosis in the biology, guys? Suppose we have a cell, and inside the cell we have a low concentration. Outside of the cell there is a high concentration of solute. If you remember, we talked about the osmosis, the movement of the solvent through a semi-permeable membrane from a low concentration side, or the pure solvent, to the high concentration side, guys. So here suppose this is the membrane of the cell, From the low concentration side, the movement of the water, the solvent, will be to the high concentration side. And that causes the cells to shrink. Shrinks the cell. The other cell, inside the cell we have a high concentration, outside the cell low concentration, guys. From the low concentration there will be movement of water to the inside of the cell, and in this case the cell swell. So this osmotic pressure must be applied to stop the shrinking of the cells or swelling the cells, in order to not let the cell to burst the cell or to die. The cell to die, and that will be due to the osmosis. This is the application of the osmosis in the biology. Guys, with the osmosis we have another process which we call as a reverse osmosis. It's not concentrated on in our book, but the reverse osmosis is just the reverse of the osmosis. It names by the process which the movement of solvent from high concentration side, high molality, high concentration, to low concentration side, And the application of the reverse osmosis is that its procedure is just the opposite of the osmosis, because the osmosis is the movement of water from low to the high. Here we have the movement from high to low. In these industrial applications, we have many industrial applications of the reverse osmosis. Mainly they use to purify salty water, the seawater, in order to get a sweet water. So it's used to what? To purify seawater to obtain sweet water or fresh water. This is the application of the reverse osmosis. The summary of what we have done, guys, is that we talked about 7 values: delta TB, delta TF, boiling point, freezing point, vapor pressure, osmotic pressure, and the vapor pressure lowering. Guys, 5 of them, which are the boiling point elevation, freezing point depression, osmotic pressure, vapor pressure lowering, boiling point. These are all 5. I call us the G5, group 5. They are directly proportional with the molality, guys. Directly proportional with the molality. So the G5, they are directly proportional, group 5, with the molality. But the 2 others, which are freezing point and vapor pressure, which we call as the G2, group 2, are inversely proportional with the molality. So the relation can be summarized in these 2 statements. Let us talk about the electrolytes and colligative properties, guys. So far we talked about the non-electrolytes. We have dealt with the sugar, with the ether, with the alcohols. Let us talk about what's the difference between when we add an electrolyte and non-electrolyte. What will happen? Guys, you know that the electrolytes are those compounds, can be ionic or molecular. When we add them, they will produce ions. These are the electrolyte solutes. Unlike the non-electrolyte, which when they dissolve, they do not undergo through ionization or dissociation. They just stay as dissolved molecules. Here the ions or the molecules, they dissolve and ionize or dissociate as well. Ionize and dissociate as well. So we have 2 processes, guys. When we add the compounds, first of all, they undergo through the process of dissolution. And second, they will undergo through ionization and dissociation. So the compounds that undergo through dissolution, like alcohol and sugar, they undergo through dissolution, but they do not pass through the ionization and dissociation. They stay here at dissolved molecule. So in this region, we will get what? Dissolved molecule. Dissolved molecules. But the compounds like acids, bases, and soluble salts, they undergo through dissolution and then ionization or dissociation as well. They will produce ions. And in this region, we will get ions, not molecules. Or we can say we will get the separated cations and anions of the compound, whether it's molecular or ionic. So we will be talking about the electrolytes, how they deal when we add into an aqueous solution. Guys, the electrolytes depress the freezing point and elevate the boiling point much higher than the non-electrolytes. Why? Because every single unit of the electrolytes, they will produce more than 1 unit in the aqueous solution. For example, guys, if sugar, which is non-electrolyte, dissolve it, we'll get 1 molecule, one dissolved molecules from one molecule of sugar. But when we dissolve NaCl, it undergoes through dissociation and will produce two ions. The summation of the produced molecules or ions becomes 2. So the effect of the NaCl, as it produces 2 ions, will be twice as the effect of the sugar. And calcium chloride will produce 3 ions, so the factor is 3 times as the sugar, is tripled. For the NaCl, the factor is doubled, and for the CaCl2 is tripled, and so on. So the effect of electrolysis due to producing more than one ion or one particle in the aqueous solution, they will produce greater effects on freezing points, boiling points, vapor pressure, and osmotic pressure as well. For example, guys, here we have a colligative properties directly proportional to the molar concentration of solution. Colligative properties, they are directly proportional to the molar concentration of solution. So molarity of the solution increases if a solute is electrolyte. Molarity of the solution increases if the solution is electrolyte. What we mean by this? We mean you add one molecule, but it dissociates to 2 ions. One molecule, but it ionizes to 2, 3 ions. That will increase the concentration of the molecules in aqueous solution. For example, guys, 0.1 molar NaCl lowers the freezing point of solvent almost twice as 0.1 molar sugar. Why? Because one sugar molecule will produce one dissolved molecule, but the NaCl will produce 2 ions, which has twice effect as the sugar. Sucrose is non-electrolyte, and each mole produces only 1 particle. But NaCl is a strong electrolyte. Each mole of NaCl dissolves to produce 2 moles of particles in the solution. So as the moles of particles increase, that increases the effect on the colligative properties as well. Here we can see, guys, in for the sugar, when the sugar dissolves, it stays as a molecule of sugar, as one unit. But when NaCl dissociates and dissolve, it ionizes to produce two molecules or 2 particles. So the effect of 2 particles is twice as the effect of 1 particle. The 2 particles, they're going to attract the water molecules much than the 1 particle. They're going to make barriers, produce barriers in front of the water much than the 1 particle. How to calculate, guys, the delta TB, delta TF for an electrolyte solute? We talked about the 2 equations. The first equation, which is delta TB is equal to boiling point of the solution. Delta TB, boiling point of solution, minus boiling point of solvent. Delta TF equals freezing point of solution minus freezing point of solvent. This equation can be used for the electrolytes, stay unchanged. But the second equation, which we we said delta TF is equal to KF multiply M. Delta TB is equal to KB multiply M. There will be some changes in this. Due to you producing more particles, Per one formula unit, the electrolytes, they have ion factors. And the ion factor, we will be talking about the ion factor in detail, must be included in the equation for the electrolytes. Because the ion factor of the non-electrolytes 1, we did not include, we did not consider into the calculations that one. But the ion factor of the electrolytes is more than 1, that's why we have to include the ion factors. The equation becomes what? Kf multiply molality multiply ion factor, Kb multiply molality multiply the ion factor. That's for the mathematical solutions. But let us talk about the ion factor. What are the ion factor of the electrolytes? Guys, as you know, we have discussed about 5 electrolytes: strong acid, strong base, soluble salt, weak acid, weak base. The ion factor represents the number of the particles per one formula unit of that compound. Number of the particles per one formula unit of that compound. For the strong bases, guys, we have got 2 types of the strong bases. One from the group 1 plus hydroxide, like lithium hydroxide. The group 1 plus hydroxide, they have an ion factor of 2. Because when you dissociate this, you'll get 2 particles, 1 plus 2. 2 particles. It completely dissociates to form 2 particles. Second, the strong bases of group 2 plus hydroxide, they have got 3 ion factor. Like CaOH by 2 will produce Ca positive 2 plus 2 hydroxides. 1 plus 2 results the 3 ion factors. How about the monoprotic strong acid? All monoprotic strong acid, they have an ion factor of 2, guys. Like HBr. HBr plus H2O produce hydronium plus Br negative. So 2 ions exist in this strong monoprotic. The strong diprotics, guys, the strong diprotics, they have 2 steps of ionization. H2SO4 plus H2O will produce hydronium plus HSO4 negative, and then HSO4 negative further ionize to produce hydronium and SO4 negative 2. Guys, in this case, the first ionization step, the sulfuric acid acts as strong acid, so it has got 2 ions. But the second step, it becomes weak, and the weakest, they do not completely ionize. That's why we prefer to write 2.2 as the ion factor of the strong diprotics. This works for all the strong diprotics. All strong diprotics means what? We have got 2 strong diprotics in our book usually, H2SO4 and H2CrO4. For the weak acids and weak bases, guys, it doesn't matter whether it's monoprotic, diprotic, or triprotic, they partially ionize. As they partially ionize, we cannot say they produce one particle, one formula unit will produce and will ionize or dissociate completely to form the ions. Unlike the strongs, most of the acids and bases, weak acids and weak bases, they stay non-ionized or non-dissociated molecules or particles. So we have used this 1.1, we have taken 1.1 as the ion factor for the weak acids and weak bases. Because they are partially ionizable, we cannot count the number of the ions as their ion factor. Instead, 1.1. It's not 1 because they produce ions, because the non-electrolytes, they have ion factor as 1. And also it's not a lot because they are partially ionized. For the soluble salts, guys, it depends on the formula unit of the salt, the structure of the salt. For example, KCl has the ion factor of 2, IEL2, SO4 by 3, 5, and so on. How? For example, IEL2, SO4 by 3 will produce 2 Al positive, 3 positive, plus SO4, 2 negatives. 3SO4 negative 2. So how many ions formed? 5. The formed ions per one formula unit of the salt becomes as the ion factor for the salt. Let us practice a question, guys. What's the expected freezing point depression? So delta T F is a requirement for a solution that contains 2 mol of magnesium sulfate dissolved in 1 kilogram of water. Guys, magnesium sulfate, MgSO4, is an electrolyte. Will produce Mg2 positive, SO4, 2 negatives. So here we have got what? How many ions? 2 ions. So the ion factor for this is 2. Delta TF is equal to Kf multiply M multiply ion factor. The Kf is minus 1.86. The molality. Molality is equal to mol of solute per kilogram of solvent. So 2 moles is given. Divide by 1 kilogram, you'll get 2 molality. And the ion factor is what? Is 2. So 2 multiplied by 2 for 4 multiplied by 1.86 is equal to minus 7.4 Celsius. In order to see the difference, I would like to solve the same question for sugar. The same question for the sugar. If we have got 2 mol of sugar, doesn't matter whether it's glucose or sucrose, for 1 kilogram. Delta TF for the sugar is equal to Kf multiply M multiply 1. This is the ion factor of the sugar. We will not consider into the calculations. Minus 1.86 multiply 2 divided by 1 is 2. 2 multiply minus 1.86 is minus 3.72 Celsius. This is for a sugar solution. That one for the MgSO4 solution. The minus 7.4 Celsius. Why minus 7.4? Why this is minus 3.72? This is almost twice as that, because of having the ion factor as 2 and that has ion factor as 1. That's the difference between the electrolytes with the non-electrolyte in terms of mathematical calculations. What's the expected boiling point elevation of water for a solution that contains 150 grams of sodium chloride dissolved in 1 kilogram of water? Guys, in order to solve for the molality, first of all, let us is equal to mol per molar mass. Mol per kilogram of solvent. Kilogram of solvent is 1 kilogram. The mole is not given directly. 150 grams is given. Divide by the molar mass of the NaCl, which is 58.5. So this results the molality, which is equal to the The molality is equal to what? Is equal to 2.57 molar. Okay, 2.57 molar. The compound is NaCl. NaCl, when we dissociate, it will produce Na positive, Cl negative. So we have got two ions. The ion factor is 2. Delta Tb is equal to Kb multiply M multiply ion factor. I effective or ion factor. So the ion factor, guys, is 2. The molality is 2.57 and Kb is 0.51. You'll get the result of 2.6 Celsius as the delta Tb of the NaCl. The freezing point of an aqueous solution of sodium chloride is minus 0.2. Find the what molality. So the freezing point of the solution is minus 0.2 Celsius, and if the freezing point of the solution is given whenever the water is the solvent, directly is equal to delta Tf. So we can say it's equals to the delta Tf of the solution. And sodium chloride NaCl has the ion factor of 2, so minus 0.2 Celsius is given. M is equal to what? M is equal to delta Tf divided by the Kf multiply ion factor, or I effective. This is the calculations, guys. Minus 0.2 divided by Kf minus 1.86 multiply by the ion factor, which is 2. This equal to minus 0.2 divided by minus 3.72. That will be the answer of the molality, the answer in molality, which is 0.054 molar. Actual values for electrolyte solutes, guys. We will be talking about two values, the expected and actual. But let me define what's the expected value and what's the actual value first. The expected value, guys, expected is the value which obtained through mathematical calculations by using equations. It's not experimental. What we have done so far is all expected tasks, expected values. We have solved the questions mathematically, without performing any practical experiments, without checking whether the solution has the same actual values of boiling point and freezing points or not. So the expected value are those values which we obtain through the mathematical calculations, theoretical. But the actual values, guys, the actual can be obtained through experiments in the lab, in the laboratory. We said, for example, the delta Tb of water is 2.5. We have expected, theoretically calculated. If we want to get the actual value of this, we have to do the experiment in the lab. Boil the same solution with the same molality of the water and wait till it has the boiling point. It reaches to its boiling point, and we will measure the boiling point elevation actually in the lab. So the actual value can be obtained from experiment and the expected from the theoretical calculations, guys. What will be the reason behind having different value for the actual and expected? The reason is the ion attraction. Attraction between the ions. We'll be talking about this in detail. But the attraction between the ions in the electrolyte solutions is the reason behind of having different values between actual and expected. But we can say there is no difference between actual and expected values of a non-electrolyte because they do not form ions. There is no ions in their solutions. So for the non-electrolytes, guys, we do not have difference between actual and expected values. Sugar and alcohol, they have the same actual and expected boiling point, freezing point, osmotic pressure, vapor pressure as well. The attractive forces that exist between dissociated ions in aqueous solution causes a difference between the expected and actual values. The freezing point depression of a compound that produces two ions per formula unit is almost roughly twice that of a non-electrolyte solution. We will use almost. Why? Because it's not exactly twice. Because actually there will be attraction between the ions of that electrolyte and will not result the exact effect of the ions. The same, the freezing point of a compound that produces three ions, it's almost 3 times that a non-electrolyte solution. For example, the freezing point of sugar is minus 1.96, for the NaCl is minus 3.72, for the CaCl2 is minus 5.58. Minus 3.72, minus 5.58. Minus 1.86. So the freezing point of NaCl, which has almost 2 ion factor, it's almost twice as that because of having attraction between the ions. We cannot say exactly. And the freezing point of the CaCl2 is 3 times as the sugar. Here we have a table, guys, to understand what's going on by increasing the concentration. But first of all, I would like to explain the reason behind the difference. We said the reason is what? Is the attraction between the expected and actuals. Sorry, guys. Suppose we have a solution. This solution contains an electrolyte of KCl. And when we add KCl, the KCl dissolve and dissociate to K positive, Cl negative. K positive, Cl negative. There will be several K and Cl as dissociated and individual ions. Okay, guys. You know that in any field of science, whether it's physics, math, or chemistry, if there will be two opposite signs in a medium, they attract to each other. For example, in magnetic field, the opposite poles of a magnet, the south and the north, they attract. In this medium, because of having two opposite ions, actually there will be attraction between those ions. And guys, as the ions, they attracted to each other, as the ions attracted to each other, they will combine and act as a cluster of particles which non-dissociated or non-ionizing. At that time, the actual value will result a different value than what we expected. Because in expected calculations, theoretically, we did not consider this attraction. But actually there will be attraction between the ions, and as the attraction between the ions actually exists, the ions, when they attract to each other, they will be like a single unit, not two units for one formula unit. They combine, they will be like a non-dissolved salt, and then at that time there will be a different value of the actual than what we expected. That's the attraction between the ions, guys. Have a look, guys. As we increase the concentration, what will happen to the value? This is supposed to be 2, the ion factor. The expected one is 2. For a 0.001 molar, it's 1.97, close to the what? To the 2. But for 0.01 molar, it's 194, reduces. But for the 0.1 molar, it's 185, reduces more. Have a look to the MgSO4 the same. As we increase the molality, the actual effective ions decrease, guys. This should be MgSO4 2. BaCl2 should be 3, the actual, the theoretical, the expected factors. But as we increase the molality, what will happen to the actual values? Of course, decreases. We will be talking about this in detail. What's the reason behind the actual, as we increase the concentration, what will happen to the actual values? Guys, as we increase the concentration, for example, each 1 molar will produce, suppose that will produce 5 dissociated ions. K positive, Cl positive 1, 2, 3, 4, 5. How about another container that has 2 molar? Another container that has 2 molar. Okay, will produce twice ions as the above one. So solution A and solution B. Okay, Cl 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Let us gradually understand what will happen to the difference between actual and expected as we increase molality. Guys, as we increase molality, you can notice we have increased the ion concentration. So as the molality increase, this concentration of the ions increase. And in a medium, in a solution which has more ions, there will be more attraction between the ions. In this medium, there will be more attraction than the above medium because we have much more ions existing. So what will happen to the attraction between ions? Increase. And as the attraction between the ions increase, there will be a fewer effective concentration of ions. What we mean by the effective concentration of ions? We mean exactly the free individual ion concentrations in the solution. So as the attraction between the ions becomes more, what will happen to the effective concentration of the ions? The actual concentration of the ions, it reduces. So ion effective concentration reduces. Guys, as the ion effective concentration reduces, there will be a longer distance between the values of the actual and expected. So actual goes further from expected. As the molality increase, ion concentration, the number of the ions increase, the attraction between the ions increase. As the attraction between the ions increase, the ion effective concentration decreases, and then the actual goes further from the expected. I have stated this here, guys. As the molality increases, more ions exist in the solution. There will be more attractions between ions, and this reduced ion effective concentration results of having greater difference between actual and expected values. If we have the same electrolyte, guys, for example here NaCl, all the solutions are NaCl, we can decide, base it on what? Base it on the concentration. The one with the higher concentration has higher difference, results a higher difference between actual and expected value. So the higher concentration, when the solute, the electrolyte is the same electrolyte, when the solute is the same electrolyte, the concentration can decide which one has a higher difference between actual and expected value. As we said in this table, guys, the one with the higher concentration, has the higher difference between actual and expected. 2 is the expected value for each of them. The distance between 0.1 molar, 0.01 molar, or 0.001 molar. This is the molality, has the difference of 0.15. And this one is expected, guys. This one is the actual. 1.94, between 1.94 and 2 is 0.06. Between 1.97 and 3 is 0.03. So as you can see that, guys, as we decrease the molality, the difference between actual and expected value decreases, lowered. But as we increase the molality, the difference between actual and expected values increase. So the difference between actual and expected value increase by increasing molality. Here we have a statement, guys. As charge increase, actual values of 5 groups decrease and the group 2 increases. Guys, keep in mind that the group 5, what we mean by the group 5, we mean delta TB, delta TF, boiling point, vapor pressure lowering, and osmotic pressure. If the question talks about the actual value of these 5 values, always the actual value of this 5 of G5 is lower than the expected. The actual value of the G5 is lower than the expected. But the actual values of freezing point and vapor pressure, which we call as the G2, is higher than the expected values. So whenever there will be questions, you have to be forecasted about that, whether the question is about the colligative properties, the values of the G2 or the values of the G5. If it's about G5, they have a lower actual value than the expected. If it's about G2, they have a higher actual than the expected. Let us answer this question, guys. Which one has a greater difference between actual and expected values? Of course, the higher molality or the highest molality represent the highest difference. 1 molar, 0.1 molar, 0.001 molar, all are the same. This is incorrect. C is the correct answer. Why? Because it has the highest concentration. It represents the highest difference as we solve it on the table. How about, guys, if sometime the concentration cannot decide when the solutes, the electrolytes are different electrolytes. For example, in our case, suppose we have 1 molar of NaCl and 1 molar of MgSO4. They have the same molarity and the same ion factor. Ion factor of each of them is 2. Guys, whenever 2 electrolytes with the same molarity and ion factor, we have to pass to the charge of them. As the charge increases, effective ion concentration decreases, and then actual unexpected values, there will be a greater distance between them, guys. We have this statement: higher charges, guys, higher charges, charged compounds attract each other much stronger than lower charged compounds. Lower charged. Higher charged means, for example, MgSO4 is positive 2, negative 2. KCl is positive 1, negative 1. The attraction that exists between the higher charge is much than the attraction between the lower charges. So, guys, as the charge increases, let us conclude a statement. As the charge increases, there will be more attraction between the ions. So what will happen to the attraction force between the ion? Attraction force between the ion increase. The ions, they attract more. They become more clustered. And then as the attraction between the ions increase, the ion effective concentration decrease. And as the ion effective concentration decrease, there will be a longer distance between actual and expected values. So the actual goes farther from expected, goes farther from, or gets farther from expected value. Let us conclude that, guys. A higher charge, higher difference between actual and expected. Higher molality, higher difference between actual and expected. And as the charge increase, guys, we stated the group 5, the actual value of the group 5 decreases, but the actual value of the group 2 increases. And the relation between I effective to the concentration is what? Is inversely proportionality. The I effective to the charge as well is inversely proportional. So the effect of having high concentration is the same of having higher charge. As the concentration increases, the ion effective concentration decreases, and then there will be a greater difference between actual and expected. The same as the charge increase, there will be a lower effective concentration of ions, and there will be a longer distance between the actual and expected values. Let us solve this question if we have different. Which one has higher boiling point? Actual boiling point, of course. Guys, the first one molality of NaCl has 2 ion factor, 1 molality of MgSO4 has 2 ion factor, 1 molality of sugar has 1 ion factor, all are the same. The sugar, the one that asked about is boiling point. And boiling point is among which group is among the 5 quantities. And the 5 quantities, guys, the boiling point, it's directly proportional with the concentration and ion factor. So the one that has the least concentration, or the concentration are the same, but the least ion factor must be cancelled. The A and B remain. The remainder of the A and B. Let me show you on the coordinator, guys. Whenever you have something about the group 5, take the boiling point as an example and you will be able to solve the actual values. Suppose this just suggestion, suppose any boiling point. Suppose it's 102 Celsius, the boiling point of the expected. This is just suggestion, guys. And then where should be the actual boiling point of those 2 electrolytes? Boiling point is among the 5 groups, and we said their actual is lower than the expected, so should be lower than the 102. For example, one here, one there. Suppose it's 101.75 and the other 101.50 Celsius. Guys, which one should be for NaCl, which one for MgSO4? The one with the lower charge and 2 negatives. The one with the lower charge, there will be a shorter distance between actual and expected, but the one with the higher charge, a higher difference between actual and expected. So let me suppose it's A and B. The A refers to which of them? Of course, the distance between expected and A is smaller than the expected and B. So this will be the actual boiling point of NaCl, and the one which is farther from the expected will be the actual boiling point of MgSO4. And so which one has the higher or highest actual boiling point? Of course, the NaCl has the higher actual boiling point. Guys, we have some notes. As the concentration of electrolyte increase, actual and expected values differences become small, and because the attraction between ions becomes stronger, so effective concentration decrease. Ions of higher charge attract other ions very strongly. They therefore cluster more and then have lower effective concentration than ions with the smaller charges. The salt applied to icy roads are electrolytes. They lower the freezing point of water and melt the ice as well. For non-electrolytes, we will take the iron factor as 1. For the to solve the 6 is important, guys. Which sequence we have to follow to solve the questions related to the actual? First of all, take the priorities for the electrolyte or non-electrolyte. You have to decide whether it's electrolyte or non-electrolyte. If it's electrolyte, it will produce more ions. Non-electrolyte, it will produce lower molecules. First, and then concentration and ion factor. Concentration and ion factor. So the first one is electrolyte and non-electrolyte. And followed by what? By the molality and ion factor. And finally, by the charge, guys. So please follow this sequence in order to solve the actual values. If they do not have the same ion factor and molality, do not pass to the charge, because most of the time the molality and ion factor, if they are different, they will decide prior to the charges. Which of them has the highest actual boiling point? Highest actual boiling point. Guys, this is 2 multiply 1 is 2. The multiplication of ion factor and molality. 1.1 multiply 3 is 3.3. This is 2 multiply 1, 2, and this is 1. Of course, the one with the higher, this is about that. This decides in where? In the ion factor and molality. We do not pass to the charge. So B is the correct answer here. The one with the higher ion factor and molality results a higher actual boiling point. Which one has lower actual freezing point? Lower actual freezing point. For the freezing point, guys, follow the same strategy as boiling point, but on the coordinator. Suppose the expected values, determine the expected values as 2 multiply 1 is 2. 1.1 multiply 1 is 1.1. 2 multiply 1 is 2. 1. And if we multiply these values by minus 1.86, minus 1.86 to get the delta TB, minus 1.86, all multiplied by minus 1.86. The sugar will be where? Will be in the minus 1.86. The 86. The phosphoric acid will be a little bit lower than this value. A little bit lower than this value. Suppose it's minus 1.95. Suppose this, I don't know. Because when you multiply this by 1.1, you'll get a higher value than, or we can say a lower value, of course, than the what? The more depressed freezing point than the sugar. And then for the NaCl and MgSO4, we'll get what? A minus 3.72 Celsius. These values that we highlighted in green, in blue, guys, are what? Are the values of expected. Expected. Which one has the lower actual boiling point? So the one that has the lower actual boiling point than the others, the solution of the phosphoric acid and sugar, they have higher actual freezing point. Sorry, guys, but the NaCl, which is A, and the C, they have the same actual sorry, they have the same expected freezing point. If you remember, guys, if you remember, I told you the freezing point and the vapor pressure, which are among the two groups, freezing point, they have a higher actual than the expected. So, suppose we have two lines here, two lines, the first and the second. Which one do you prefer, guys? Which one do you prefer to the NaCl? Which one for the MgSO4? Of course, the one that's closer to the expected value must be for NaCl because it has lower charge. The one which is farther from the expected must be for MgSO4. So the first one is what? NaCl. And the second one is MgSO4. So here, which one has a lower, not higher, lower actual boiling freezing point? Of course, the compound that has a higher actual or the lower actual, lower actual freezing point is, the lower means what? We mean farther from zero, farther from zero. If it requires higher, we mean the closest to the zero. So the one has the lower freezing, actual freezing point depression, which is NaCl, guys. The question, the other question, guys, let us solve the other one. Which of the following has highest actual boiling point? This is the Ministry of Exam question, guys. I would like to provide a table to this, guys. The options or the solutions, the molality with their ion factor, and then expected, and then actual values. The first solution is what? 0.2 molar of sugar. 0.2 molar of sugar is what? So we have sugar, KCl, MgSO4. The molarity is 0.2 multiplied by 1 is 0.2. KCl is 0.1 multiplied by 2 is 0.2. MgSO4 0.1 molar multiplied by 2 ion factor, you'll get 0.2 molarity multiplied ion factor. This is molarity multiplied ion factor. What will be the expected boiling point, guys? In order to get the boiling point, we have to multiply the ion factor with the molarity with what? With the Kb. And then add by 100. The Kb multiplied by each of this value, 0.5 multiplied by 0.2, you get 0.1, 0.1, 0.1. And then the summation, you get 100.1 Celsius for all solutions. So the three solutions, they have the same expected boiling points. Okay. How about the actual? D is correct, guys, if it's not stated actual, because they have the same expected boiling point. The actual of sugar is the same as expected, 101.1. We said that. But for the KCl and MgSO4, the boiling point is among the group 5. And the group 5, they have a lower actual than the expected. So must be what? Must be less than 100.1. This one less than 100.1. Why? Because these are two solutions which are electrolyte. They have a lower actual boiling point than they expected. Most of the students, they have chosen MgSO4, but the answer is what? Is sugar. Why? Because which one has the highest actual boiling point? Of course, sugar solution. These two, they are less than the boiling point of sugar. That was a tricky question somehow in ministerial exam questions. Let us solve some questions, guys. Why is boiling point elevation a colligative property here? Because it depends on is directly proportional to the number of the solute in a solution. Yes, because it's affected by the amount of the solute. Compare it with the 1 molar sugar solution. A 1 molar KBr solution has. Guys, for such questions, the option is given are the properties of the second compared to the first. So the boiling point of the KBr is almost twice as what the sugar, and freezing point almost twice lower than the sugar. So the same boiling point elevation, no, exactly twice the freezing point depression. This is what? About twice the freezing point depression, the same freezing point depression. Guys, for these questions, comparing with the electrolyte with non-electrolyte, do not choose the same, because they are not exactly the same when you compare electrolyte and non-electrolyte. The electrolyte has twice freezing point depression lower than the non-electrolyte, because it has 2 ions. So exactly twice, no, not exactly twice. About twice the freezing point depression, yes, C, about twice, or roughly twice. Compare it with 1 molar NaCl, the same question, 2 molar sugar. So the solutions below are the property of the options property of that solution. About twice the boiling point elevation, about twice the freezing point depression, higher vapor pressure, higher boiling point. Guys, the sugar, 2 molar of sugar, multiply 1, you get a expected value, it's 2. And 2 ion factor, multiply 1 for, this is for sugar, for NaCl, you get 2 as well. So they have the same expected effects, the same expected effects. That's why it's not almost about twice or something like that. Because the molarity of the sugar is 2, we multiply by its ion factor, we will get results of both 2. Higher vapor pressure, the solution of sugar, or the higher boiling point. Guys, the vapor pressure, actual vapor pressure, is higher than the expected. So, but the boiling point, actual boiling point, is lower than the expected. So the actual value of boiling point of this is lower than the sugar. That's why the sugar has the higher boiling point than the NaCl actually. But higher vapor pressure, guys, the higher vapor pressure, which one has the higher vapor pressure? Of course, the one with the lower effective concentration. And this has a low effective concentration. So it's not true. So the sugar has a higher boiling point compared with the NaCl. The KCl dissolves in water. The vapor pressure of a solution, of course, decreases, guys. Which of the following compound will be most effective in lowering the melting point of ice on rollers? This has got 2 ion factors, 1 ion factor, 3 ion factor. The one with the higher ion factor has higher effects, guys. The calculations, guys. What's the boiling point elevation of 1.2 molar sugar solution? So the boiling point elevation is equal to delta TB. It's for what? For sugar. KB, which is 0.51, multiply 1.2. So you'll get the value of these options. What's the molar freezing point of a sucrose solution whose freezing point is -4? It's the same as the other questions, guys. Boiling point of a solution, prepare it by dissolving 0.12 mole of barium chloride in 0.15 grams of water. So divide the mole by the kilogram, you'll get the molality. Multiply the molality by the ion factor of barium chloride, which is 3, and 0.551, which is the kb, you'll get the value. Which of the following solutions that have concentration of 0.1 molar show the highest elevation in the boiling point? They have equal concentration of 0.1 molar for each. 0.1 molar for each. The ion factor of this is 2, this is 3, this is 1.1, this is 1. Of course, the one with the higher ion factor, and we multiply by the concentration, will result of having highest elevations. But if it requires the freezing point and vapor pressure, of course the one with the lowest ion factor and the concentration has the highest vapor pressure and freezing point as well. Cell shrinkage when placed in a concentrated solution. This is an example of osmosis. This is example of osmosis, of course. Which solution has the highest boiling point, guys? Which solution has the highest boiling point? 0.4 multiply 1, 0.4. 0.5 aluminum chloride, guys, AlCl3, has got 4 as the ion factor. So 4 multiplied by 0.5, you'll get 2. 0.2 sodium nitrate, NaNO3, has got 2 ion factors. 2 multiply 0.2, it's 0.4. Barium chloride, BaCl2, has 3 ion factors. 3 multiply 0.2, 0.6. So which one has the highest boiling point? Of course, the one that has higher result of multiplication between ion factor and molality, which is the B. Compare it with the boiling point elevation of 1 molar sugar solution. The boiling point of KCl solution is what? Is almost twice as exactly twice or almost twice as great as the sugar solution, guys. What concentration of ethylene glycol is needed to raise the boiling point of water to 103 Celsius? The mechanism of this solution is what? It requires the M, molality, of the ethylene glycol. Ethylene glycol is non-electrolyte, guys. So delta TB is equal to what? Is equal to Kb multiply M. In order to find we have got Kb 0.51, okay? The concentration is the requirement. The boiling point of a solution is given. The boiling point of solution minus the boiling point of the solvent, which is water, 100, it will be 0.3, 3. So the delta TB here is 3. Molarity is equal to what? 3 multiply 0.51. So this will be the result, guys. What's the approximate freezing point depression? This calculation, I will not be solving calculations, guys. What kind of colligative properties are displayed by the following solution? Ice melts on sidewalks after salt has been spread on them. Of course, freezing point depression. 10 molar NH3 ammonia solution is what? Is concentrated but weak electrolyte. The following 1 molar water solution in order of decreasing freezing point, guys. Decreasing freezing point. Decreasing order means from the highest freezing point to the lowest. Of course, the one that has highest freezing point has least ion factor and least concentration. But here, the concentrations are equal, so start from the least ion factor, then higher, then highest ion factor. The ion factor of NaCl is 2, So NaCl is 2, glucose is 1, CaCl2 is 3, CH3COOH is 1.1, Na3PO4 is 4. So the order of decrease in order must be from the lowest number of these numbers to the highest. The lowest it's 1, it was for the glucose. So the glucose must be the first. And then it has the highest freezing point. Then 1.1, it's what? CH3COOH. And then 2 is what? NaCl. Which one has this sequence? So let us see. Glucose, CH3COOH, NaCl, and then 3 CaCl2, and then Na3PO4. So D is the correct answer. In this direction, the freezing point lowered, but in the opposite direction, the freezing point increases. We have got some ministerial exam questions, but let me solve the standardized test, guys. Standardized test prep. We have got so many here. The chapter review. We have solved the chapter reviews, guys. Let us solve the standardized test prep, guys. Standardized test prep. Almost all the rounds of ministry of the Ruby questions appears in the ministry from the standardized test. Acetic acid is a weak electrolyte because it's miscible with water, forms hydronium and hydroxide ion in aqueous solution, lowers the freezing point, ionizes only slightly in aqueous solution. Because the weak electrolyte, it depends on what? Ionized partially in the solution. That's why it's electrolyte, weak electrolyte. Which of the following solution would contain the highest concentration of hydronium ions in solution? 0.10 HCl, 0.10 HF, 0.10 molarity CH3COOH, or NaCl. So highest concentration of hydronium must be the strongest acid. So which one is the strongest acid? Of course, A is the strong acid. Which of the following is the best representation of a precipitation reaction that occurs when an aqueous solution of sodium carbonate and calcium chloride are mixed? Sodium carbonate, guys, Na2CO3 plus calcium chloride CaCl2. It requires what? The precipitation reaction that occurs between them. Let's just complete it. CaCO3 will be the product, and NaCl is the other product to NaCl. Requires the precipitation reaction. Precipitation reaction means the net ionic equation. Net ionic equation. So the net is what? This is insoluble, you know that. CO3 2 negative plus Ca positive will produce CaCO3. Of course, aqueous in the reactant and the precipitate in the product. So which one is in this form? The first one is not, the second is not, the third, the C is the correct answer. Which of the following is not a colligative property? This appears in ministerial exam, guys. Of course, molarity is not a colligative property. Guys, the solution A contains 0.1 molar sugar dissolved in 500 grams of water. Solution B, 0.1 molar. So A, solution A, 0.1 molar, 1 mole sugar, 500 grams. So the concentration will be 0.1 divided by 0.5. Okay, that will be the concentration. And solution B, the same amount, 0.1 divided by 0.5. This will be the same concentration. But the ion factor of this is 1. The ion factor of this is 2. Which of the following is the correct answer? Both solutions have the same vapor pressure? No, because this is electrolyte. This has a lower vapor pressure than the non-electrolyte. Guys, the solution A, which is non-electrolyte, would boil at a higher temperature? No, at a lower temperature. Solution A would freeze at a higher temperature? Yes, the solution A, because it has got lower effect ion concentrations, lower particles of ion factor. It freezes at a higher temperature than solution B. So C is the correct answer. Guys, for this table, the table is given for X, Y, Z, and the concentrations are equal. The kilogram of water is equal, but we represent what? Different freezing point of the solutions. Which of the following is not true? So the statement is said not true. All three solutes are non-electrolytes. It's not true. I mean, all three solutions. So the A is the correct option. Why? Because it's wrong. The solution of that they have different freezing points is this is sugar, guys. This seems to be one of the KCl or NaCl that has two ion factors. This is that has three ion factor, BaCl2, for example, something like that. So all the solutions, they are not non-electrolyte. Of course, only solution Y is non-electrolyte. X and Z, they are all electrolyte. Solute X could be CaNO3 by 2. X, yes, as I told you, it must be 3 ion factors. It's true. Solute Y could be sugar or sucrose. Yes, I told you it's non-electrolyte. Solute Z could be KCl. I said KCl or NaCl that has 2 ion factors. For the same solution, guys, for the same question, which of the following solution described in the table would have the highest boiling point? Highest boiling point. Okay. Of course, guys, the highest boiling point results to the freezing points as well. Freezing points X, Y, Z. The one, guys, the one that has highest boiling point must have lowest freezing point. So the lowest freezing point has highest boiling point. Which one has lowest freezing point? Of course, X has lowest freezing point. So the solution of X has the lowest freezing point